This is Math 6, Module 4, the end of the module review. Number 1 says, Yolanda is planning out her vegetable garden. She decides that her garden will be square. Below are the possible sizes of the garden she will create. So we got a square garden, which means the length and the width are the exact same. So if we have a 2 feet, the side length, which means both the length and the width, that means we're going to have a 2 squared garden, which would equal 4. Because length times width, 2 times 2 is 4 feet squared. And then there you go. There's your 2 by 2, which means there's 4 1 feet squares. Do you see that? Okay. So 3 would be 3 squared, which is equal to 9. Because 3 times 3 is 9 feet squared. So we would have that's not a good square there, for sure. That's not going to work either. 1, 2, 3, 4. There's 9 squares. Okay? And so on. So 4 squared gives us 16. Because 4 times 4 is 16 feet squared. And then do we understand so far? Everybody good? You should be able to fill out the rest of that then. Except for, I'm not going to do 5, I'll do the x. So we would have x squared because x times x is x feet squared. X squared, feet squared. Okay? And so you would just draw a box that has x by x, because we don't know. All right. B, Yolanda decided the length of her square garden will be 17 feet. She calculated that the area of the garden is 34 feet squared. Determine if Yolanda's calculation is correct. What did we say? No, she did 17 times 2. She should have done a garden that is 17 by 17, 289 feet squared. She has a 17 feet by 17 feet garden. Okay? You got to be careful. Don't do times 2. It's all right. Page 2 says, Yolanda, she's all about building something, ain't she? She creates a garden cubes to plant flowers. She will fill the cubes with soil and needs to know the amount of soil that will fill each garden cube. So we're talking about volume here. The volume of a cube is determined by the following formula. V is equal to S cubed. That's the reason why we call it S cubed, S to the 3rd power, where S represents the side length. Represent the volume in cubic inches of a garden whose cube above using numerical expression. So that would be what? 32 cubed, which equals 32 times 32 times 32. Okay. All right, so if we did that, because it says evaluate the expression, that would be 32 cubed, and that is equal to, everybody at 32,768? And that would be feet cubed. Do it. Do the expression, yeah. Okay. Number 3 says, explain why 1/2 to the 4th is equal to 1/16. So whenever it says explain, what are you going to do? What do you mean write it? Like you're going to say, it is because. You could do that, or you could just work the problem out. How would you work this problem out? Well, we would say, correct, 1/2 times 1/2 times 1/2 times 1/2. And I would do this. This would be 1/4. This would be 1/4. 1/4 times 1/4 is 1/16. Celine. It does, but I would just keep it because you're dealing with it as equivalent to a fraction, so why not just do fractions? Okay. Page 3. All right, Yolanda, man, she is busy. We call her a busybody. She's always working. Yolanda is building a patio in her backyard. She's interested in using brick and wood for the flooring of the patio. Below is the plan she has created for the patio. All measurements are in feet. Create an expression to represent the area of the patio. So, well, yes, but you're going to have to write it out. We're going to have to create the expression. Well, we're going to have 12.5 times 3 plus x. Okay? Or, what would we say? What does that equal? Right, so that would be 37.5 plus 12.5x. Yo one. I got Yolanda. I went yo one. Yo one. Yeah. Because you're adding the brick and the wood together. 3 times 12.5 would just give you the brick. But we also need to add the wood one to it. So it's 12.5 times x. So if you're doing 12.5 times 3 and 12.5 times x, you can just add those two together. It's the same thing. Okay. Now, Yolanda's husband, now she's got to get her husband involved here, develops another plan for the patio because he prefers the patio to be much wider than Yolanda's plan. Determine the length of the brick section and the length of the wood section. Then use the dimensions to write an expression that represents the area of the entire patio. Now, just like up here, this area of the brick would be 37.5, and the area of the wood would be 12.5x, right? Now we're given the area, and we're given the width. Now we got to determine the length. So, how are you going to do this? We're going to take our area, divide by our width, and that'll give us our length, right? Let's think. Area equals length times width. So if I'm trying to find the width, find the, where we find it? The length, we're going to divide by W. So A divided by the area divided by the width gives us our length, right? So let's take, what is that, 48x? 48x divided by 24 gives you what? 2x, correct. That is 2x. So up here we would write 2x. Now we would do 96 divided by 24. And what do we get? 4. Just 4. So there's our 4. Everybody see that? Hmm? Yes. Okay. Now, number 5 says the landscaper hired for Yolanda's lawn garden or lawn suggests a patio that has the same measure of wood as it has brick. Express the perimeter. We're talking about perimeter, not area, of the patio in terms of x. First using addition and then using multiplication. So if we're going to do it using addition, what do you do to find perimeter? Add up all the edges, right? So we would just say plus, 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 plus. So we would have x plus 2x plus x plus x plus x plus 2x plus x plus x. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everybody got 10x? Okay, good. Me too. Now, how would you do it doing it by multiplication? How would you... That is the multiplication, right? Since we only have x's, this is how you would do that. You would just say 10x. You would count up all your x's and put the coefficient out front. That's all you could do. Okay, B says use substitution to determine if your expressions are equivalent. Use substitution. What do they mean by that? Okay, so if we say let's use x equals 3, okay, I'm going to come over here and I'm going to write 3 plus 2 times 3 plus 3 plus 3 plus 3 plus 2 times 3 plus 3 plus 3. And what do I get? Well, 3 plus 6 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, plus 6 is 24, plus 3 is 27, plus 3 is 30. Now I would also say 10 times 3 equals 30. Therefore, they both check out. They are equivalent because when I substitute a number for x, they give me the same thing. So I know that this expression and this expression are equivalent. All right, page 6. Number 6. Elena and Jorge have similar problems and find the same answer. Each determines that the solution to the problem is 24. There's Elena's problem and Jorge's problem. Evaluate each expression, determine if both Jorge and Elena are correct. Okay? It's not what? Well, that's how most Hispanics spell Jorge. I don't know. It could be George. You want to call him George? George or Jorge. Okay. So what do we do first? PEMDAS. What does PEMDAS tell us to do first? Parentheses. What's 14 plus 42? Plus 7 plus 4 squared. Now what am I going to do? Exponent. What's 4 times 4 or 4 squared? Is that a plus or division? Oh, that is. Got to be careful then. Okay. Well, I knew we were going to get nowhere close to 24 if all of those were additions, so I knew something was wrong. Now what are we going to do? We got to divide first, correct? PEMDAS, D comes first. So that would be 8 plus 16, which equals 24. So Elena's definitely right. Let's see if George or Jorge is correct. Same thing, we got to do PEMDAS first. What's 42 divided by 7? 6. So I got 14 plus 6 plus 4 squared. Well, we got to do exponents again. So that's 16 plus 6 plus 14. And I know 14 plus 6 is 20 plus 16 is 36. So George is not correct. Only Elena is correct. Evaluate each expression. Oh, we did that. That was A. All right. B says, why would each find the solution 24? What mistakes were made? Well, Elena didn't make any mistake, did she? She got the correct answer. What did George do, though? What did he do? No, but why did he come up with 24? What did he actually do? He ignored the parentheses, didn't he? He didn't solve the brackets first? Let's see here. How would he have come up with that? He would have said, well, that's the reason why it was wrong. But how did he get 24? It looks like he ignored. He just worked it out from left to right, didn't he? He said 14 plus 42 is, he ignored his parentheses. He worked left to right, ignoring parentheses and ignoring exponents. He just worked everything out starting from left to right. Okay. Number 7. Jackson gave Lena this expression to evaluate. 14 times 8 plus 12. Lena said that to evaluate the expression was simple. Just multiply the factors 14 and 20. Jackson told Lena she was wrong. He solved it by finding the product of 14 and 8 and then adding that to the product of 14 and 12. Evaluate each expression doing what the student said. Okay, so 14 times 20 is 280, correct? Jackson says he done 14 times 8 plus 14 times 12. Well, what's 14 times 8? 112. Plus, what's 14 times 12? 200, 280. 280, correct? Okay. So why are they? So who was right? Both. Yeah. So the order of both order of operations are correct. Yes. Jackson used distributed property. That's it. All right, page 5. We're doing on time. How many more pages have we got? Okay. Y'all just did this one on your homework, didn't it? All right, here we go. Gertrude is deciding which cell phone plan is the best deal for her to buy. Supercell charges a monthly fee of $10 and also charges 15 cents per call. She makes a note that the expression is M equals 15 cents C plus 10, where M is the monthly charge in dollars and C is the number of calls placed. Global Cellular has a plan with no monthly fee but charges 25 cents per call. She makes a note that the equation is M equals 0.25 C, where M is the monthly charge in dollars and C is the number of calls placed. Both companies offer unlimited text messages. Make a table for both companies showing the cost of service. M for making from 0 to 200 calls per month and using multiples of 20. So how many? So 0, 20, 40, 60, 80, 100. And I'm going to come over here and say 120, 140, 160, 180, and 200. Okay? So if I plug that into Supercell, all we're doing, we now know C. This is C. These are our C's, right? So we're going to take those C's and plug them into the formula or the equation to get our M. So if we plug in 0 to Supercell, what do we get? Yeah, we still have 10. What about if we plug in 20? What about if we plug in 40? 19, 22. And now listen, why are they going up by 3 each time? We're not multiplying by 3. Why are they going up by 3 each time? Okay, each call is 15 cents, but how does that make out to be adding 3 each time? What did we do? We done intervals of 20, correct? So what is 0.15 of 20? What is 0.15 of 20? 3. That's why it's going up by 3 each time. Because we're doing intervals of 20. And if we multiply that by 0.15, that is 3. So it's just going to go up by 3 each interval of 20. Okay? Each interval of 20. not each call, each interval of 20. Okay? Now we got to do global cellular. So this is just saying a quarter of each call is how much it's going to cost you. So what is a quarter of 0 calls? Okay. What's a quarter of 10? I'm sorry, a quarter of 20? 5. What's a quarter of 40? Does it just go up by 5s each time? Why? Something I said, yeah. Yep. The interval of 20, if we multiply that by a quarter each time, that is 5. And so we're going up by 5 each time. Correct. Okay. B, construct the graph. Now, I'm not going to exactly do this graph just for the sake of time, but surely you can list out what is going to be your X. X will be the, say it a little bit clearer. Call, yes. X will be the call. X is going to equal your calls. And the Y is going to be the cost. Okay? Dependent is Y. Your cost depends on your calls. The independent is X. Now, what I said I was going to do. I'm going to do, let's do supercell in red. And supercell is going to look something like this. It starts at 10. So it's going to look something like that. And if I do, let's do black. Black will work. If I do global, we're going to start at 0. Oh, why didn't we go? Why is it not wanting to change my color? Let's go with, well, that's going to be black. So global, it starts out cheaper. It started out at 0, right? But it goes up a lot faster. Actually, did I do that right? Yes. Oh, I wrote those down. I put 100 out there here. That shouldn't have been 100. There we go. Now what? Well, you did it wrong. I'm kidding. What'd you do? No, you want to do it because you can't really see on this. You want to plot it on the same one so you can see which one's better. If you plot it like I did, you can tell that if you're not going to make that many phone calls, right, then you would want to. So at this point right here, where do they cross? That's the global. So look, they all cross right here at 100, at 25 calls. So if you're not going to make 25 calls a month, you would want to go with global cellular. But if you're going to make more than 25 calls, you want to go with the supercell. Do you see that? Okay. Oh, and so that's what C is saying. If you make the calls less than 25, you want to go with, what's it called, global? Go with global. Global. I wrote global. Global. If you're going to make calls greater than 25, more than 25 calls, you want to go with supercell. Okay? Everybody see that? Everybody good with that? Okay. Page 6. I did. I wrote it down there. Okay. Oh, man, we got to hurry. Sadie is saving her money to buy a new pony, which costs $600. She has already saved $75. She earns $50 per week working at the stables and wonders how many weeks it will take her to earn enough for a pony of her own. Make a table showing the number of weeks and total of savings in dollars for each week. Okay. So we have how many weeks here? 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, what is going to be it says make a table. How are we going to figure this out? What is our equation going to be? Celine? 75 plus 50 W's. Does everybody understand why we have 75 plus 50 W's? Now, I told you, though, to not write it like that. I want you to start writing it like this, 50W plus 75. It's the same thing. But when you're putting it in this form, you're going to see this form later on in algebra and stuff, pre-algebra. So be writing your constant, what's staying the same, that $75 is getting added on every week. I mean, it stays the same, right? You're not changing your 75, you're changing your 50. So put your 75 on the end. Now, you need to just get a good practice of that. I'm not going to count off. Okay. So, how many in the first week? How much money does she have? 125. How much the second week? What about the third week? Fourth week is what? Fifth week is? Sixth week? So we're just going up by 50 each time, right? Why? Because each week she's getting $50. Or 75. So now at what week will she have enough to buy her pony? The 11th week. Correct. Week 11. Because she will have $625. Okay? Let's see here. Page 3. Or question 3, page 7. It says the elevator in a local mall has a weight limit of 1,800 pounds and requires that the maximum person allowance be no more than 9 people. Let X represent the number of peoples, right? Inequality. Okay, well, how many can we have? So 9 is the most, right? So that would be, X has to be what? Less than or equal to 9. But X would have to be greater than. I don't like that, but they say greater than or equal to 0. I guess you could have 0 people in there, couldn't you? Is there such thing as 0 people? Can you have a 0 person? Could you have a half a person? Not for long. Okay. Draw a number line diagram to represent all possible solutions. Now, you do need to know how to do this for your test. But this one's tricky. Okay. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now remember how the other day I drew one dot and I did the arrow in one direction. You cannot do that here. Because can you have a 7.5 person? No. So these would all just be the dots on the 7, 5, 4. Now this one's a little bit tricky, but it's got you to think about what you can actually do. I guess you could have the 0 person. I don't like that. But normally you would just draw your dot, put your arrow in the right direction. Now it's a closed dot when what? When is it a closed dot? When do you do an open circle and a closed dot? The equal to. Yes, this is when it's equal to as well. Okay? So this is less than or equal to, greater than or equal to. This is just less than and greater than. Okay? C, let W represent the amount of weight in pounds. Write an inequality, describe the maximum weight allowance in the elevator. Well, how many pounds can it be? Let's go with W for the weight. How much could it be? 1,800. And then it would have to be the same thing. Now, here, if I draw a number line here and here, I'm just going to draw my 1,800 over here, my 0 over here. Now we can do our circle, close circle, and go to the left, and we would stop at 0. Yeah, you just got to kind of think about it. If it's people, you can't have half a person. Could you have 16.5 pounds? Yeah, so that's the reason why it's everything on the number line. All right, page 8. What do we got here? Okay, this one's easy. We have a straight line here that equals what? 180. So we have 180 degrees is equal to this angle. Let's call this angle 1, angle 2, and angle 3. So that would be equal to 51 plus x plus 51. Well, can you do it? You can't do 51 plus 51? Then we're going to do 51 plus 51. That's 102 plus x. Now, can you do 102 plus x? No, so we're going to do the opposite. We're going to subtract 102 from both sides, and we would get 78 is equal to x. So this degree for x would be 72 degrees. Oh, 78 degrees, I'm sorry. 78 degrees. Everybody understand? If that was a 90-degree angle, we would just set all the angles equal to 90. Everybody remembers that? Okay? Now, okay, good. What is the answer to number 5? Yo, 1. What? 17? Well, it sounded like you said 16, 17. You wasn't really for sure. Okay, 17. All right. Ryan, what's number 6? Everybody get negative 8? What about 7, Hannah? 217? 270, okay. Everybody get that? 8. Janice? What is 8? Negative 8. What about 9, Chloe? You just didn't do it? Negative 34. Negative 34 divided by 2 is negative 17. All right, Celine. 10. Everybody get 15? 11, Simon. Negative 2. Well, looks like I was going to get Gianna to answer one, but it looks like she left us. Here one, what about 12? Ooh, it's not going to be minus 10 because 10 times a negative 10 would be negative 100. It's just negative 1. Just negative 1. All right. Whoops. I don't have What about 13? What is it? Negative 38.
Negative 16.
I can't see it, so I don't know. Let me see here. 13. Yeah, it has to be negative 16. Negative 16 and negative 11 is negative 37. All right, 14 is 5. And 15 is negative 8. All right, go to page 9. I think I can see. Yep, 16 is what? B is equal to a negative 8. 17 is N equals 3. 18 is R equals negative 2. 19 is N equals 3. 20 is X equals 2. 21 is A equals negative 11. 22 is V equals negative 13. 23 is X equals 11. And X equals negative 4. If you can do it, do it. If you can't, do the opposite and do it to both sides.